Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, my name is Sheila Maharani and today I'm going to present you my thesis with the title of the analysis of thermal and acoustic comfort in Panti Werdha with the case study in Panti Sosial Tresna Werdha Budi Mulia 1. So this thesis will be divided into 4 main chapters. The first one is the introduction. So the background of this topic is the great population of senior citizens that happen in the world. So seeing the pattern of senior citizens in Jakarta, there are still 3% of elderly who live alone. However, with the increase in age, the elderly population is more vulnerable. So they need special attention and also protection. And one of the places where the elderly can spending their life to be cared and socialized with their peer is Panti Werdha. But there's still a lot of Panti Werdha that's far from ideal condition in terms of human comfort in architecture, especially thermal and audio comfort. They are interrelated to each other. So it comes with the question, so how to achieve a comfortable design regarding thermal and acoustic comfort, particularly for elder people in Panti Werdha. So this research will be focusing in the space for elderly. It will be dealing with the elderly everydayness, and the goal is to find an ideal space for the elderly. So these are the methods. So basically we are gonna doing the site visit on a real-time measurement. It's be supported with the interview and also the simulation. Then conclusion and recommendation can be appear. And the next chapter is the literature study. So basically we are gonna be discussing about the elderly definition and also characteristic, then the elderly housing definition purposes, then the human comfort, which is focusing on the acoustic and thermal comfort. Then we're gonna seeing the criteria on each of the comfort, and then we're gonna revert to seeing the index. So the thermal comfort index that we use is the predicted mean foot, and these are the classification. Then for the acoustic comfort, which is related to sound and noise, we're gonna be discussing the sound characteristic in classroom, and then using this noise level as our index, and then referring to the standard that we get from the SNE. It will be equated with the hostel, apartment, or dormitories. And then these are the result and discussion. Basically, the result of the measurement and calculation that we are doing in our case study. So first of all, the profile on our case study. So Panti Sosial Tresna Werdha Budi Mulia is the Panti Werdha that belong to Dinas Sosial of DKI Jakarta. It's accommodate up to 270 people. And the people that living here is the people with the social welfare problem that mostly come from the street. And these are the map of the location. It's located in Jalan Bina Marga street, which is the main road that connecting Cibubur and Kampung Rambutan. So that's why the street is quite busy and congested. And seeing the site analysis of the area, you can see the orientation and also the source of noise and the wind that comes to this Panti Werdha. And seeing the surrounding area and also the zoning, you can see that Panti Sosial Tresna Werdha Budi Mulia, it's surrounded by mostly residential area, and then also commercial and also public facilities. And then we're analyzing the climate, especially in the Jakarta. Overall, Jakarta is in the tropical climate with the highest temperature and also the relative humidity. So these are the mapping of the building in Panti Werdha. So this Panti Werdha is consists of several buildings that is located in one complex, and all of the building is oriented to the middle courtyard, which is the musola. This is the mapping of the green area in Panti Werdha. So our analysis will be focusing on the thermal and the comfort analysis, and the point that we are measuring in the place is this 4 main point with these tools. And we'll be focusing in the bedroom and also the common room. So we'll be measured in 3 position and also in 3 time. And this measurement is done in Saturday, 20 November 2021. So these are the site plan of the 2 buildings that we'll be focusing on, which is the bedroom and also the communal room. For the bedroom itself, the bedroom that we choose is Wisma Asoka, which is the bedroom that intended for the independent elderly. So the consideration is because of the location and also the activities which is more busy than the other bedroom. And these are the profile of the bedroom and the materiality that create the atmosphere inside. So it's basically dominated with brick, plastic, ceramic, and also aluminum. And these are the ventilation system and also the opening that used in the bedroom. Then for the communal room, the communal room is located in the main building, which is accessible from the main entrance. So, and these are the profile of the communal room. Then the materiality and also the atmosphere that is created. So basically, the same as the bedroom. And these are the opening and the ventilation system. So first, for the measurement, we're gonna be analyzing the thermal comfort. So these are the index that we are referring to. And then in the first room is the bedroom, and we are measuring in 3 positions, which is in position A, B, and C. And we're measuring the air temperature, relative humidity, and air velocity in each of position and each time. And we can get the PMV level and also the average in each time. So based on that measurement, we can translate it into graph. And these are the results. And from that parameter, we can get the predicted mean food, which is, if we conclude it, it is quite uncomfortable. So it is in the number of 1.9, which means this room is warm. Next is for the common room. We're measuring also in 3 position, which is position A, B, and C. So as the same as the bedroom, we are calculating the parameters to get the PMV. And these are the graph of each of the parameters. And also we can get the PMV. And to be conclude, the PMV level in the room, it's still negotiable more than the bedroom. And the PMV number is 1, which means this room is slightly warm. We're also doing a simulation with the ladybug and rhino to see the condition where we cannot measure in time. So we can see that there's a significant changes during the day and night, and also the condition is mostly comfortable in the evening or night rather than in the morning and also in the afternoon. For the analysis of the result, we can see that the PMV number for the bedroom and the common room is still higher than the standard. The analysis is because of the building orientation and also the use of the mechanical ventilation system, and also there's still a lack of heat insulation material. And for the bedroom, there are more occupants than the common room. That's why it is more harder, because the person itself can be the source of heat. And then the second measurement is for the acoustic comfort. These are the index that we are referring to. And this is the position. So basically, the position of the measurement is the same as the measurement in the thermal comfort. So based on the measurement, we can get the noise level. So it can be concluded that the noise level is quite high, but the source is mostly comes from the people and also the mechanical HVAC system inside. And we also calculate the reverberation time in the bedroom. And we can get the it is about 1 second until 2.7 seconds. Meanwhile, the ideal for the bedroom is 0.4 until 0.8, and it's still higher than the standard. And for the common, and these are the position of the common room, which is more or less the same. And for the result, we can get the noise level in the room is quite considered normal. And you can see in the graph, there's a huge difference between position A, B, and C. So the position C is where we're measuring outside. So we can see that the material in this common room can detecting the noise much better. And these are the reverberation time. We still got the result that is higher than the standard of the common room that is intended for the speech and also for the mixed activities. The analysis is because of the building position, which the communal room position is more at the front, which is less barrier. Meanwhile, the bedroom is more at the back with a much barrier. And also the use of mechanical HVAC system in the bedroom become one of the source of the noises. And there's a lot more absorber material in the bedroom rather than in the communal room. And also the activities that become the source of the noises. So based on that to analysis, we're also doing an interview as the supporting data. So we're asking about where do you feel comfortable or uncomfortable, and how do you deal with that gitu. And they say that they'll feel more uncomfortable in the afternoon, so it's always hotter in the day but cold at night. And the noises from the traffic, like in the street, it's very disturbing, even though their hearing ability has decreasing enough to be less sensitive to noise. And if they feel more uncomfortable, they will sit on the terrace or the porch to take a walk. For the result analysis, in some of condition, there are still a condition that not up to the standard. And the things to be improved is the material and the barrier. So we're also doing this simulation for seeing the incident radiation and also direction hours to support our argument, which is we can see that in the top of the building there's a very exposed to the sun, and for the recommendation that we are the recommendation is mainly focusing on 3 points, which is buffer zone, material improvement, and also the opening. And there's one more recommendation. It's to reduce the number of occupants in the room, which happening in the bedroom, because it can be the source of noise and also the source of heat from the people in the room itself. And these are the material that we comes up to our recommendation. And the last chapter, which is the conclusion, we can conclude that the comfort level of human is different, not least for the elderly. And for the elderly housing itself, there are no specific criteria, but several factors can be considered. And also, based on the result of the calculation and the measurement, we can see that in some condition, they're still higher than the standard. And the influencing factor is like the material, orientation, opening, buffer zone, or the occupant and the activities inside. And the things to be highlighted is the material, opening, and the barriers. That's all from me. Thank you for your attention. I look forward to your question or maybe any suggestion for the improvement. Thank you.